scientists found that the minimum frequency required to cause photoemission from zinc was that frequency, and therefore the minimum energy required was this, either in joules or in electron volts. But then when they tested other metals, they found that other metals had different minimum frequencies and minimum energies. And so we have these two terms. The threshold frequency of a metal is the minimum frequency of light that causes photoemission, and the work function of a metal is the minimum energy of a photon that causes photoemission. But note that the definition of work function is that it's the minimum energy required by an electron in the surface of the metal that allows it to escape. Now the work function has its own special symbol there, and so now we can say that the energy provided by the photon, some of it's going to be used by the electron to escape the metal, and that's how much energy is going to be used to do that. And then any that's left over will be the kinetic energy of the electron. Now this is maximum kinetic energy because the electron can lose some energy on its way out of the material. The value we calculate with this equation is assuming that it hasn't lost any on its way out. And so bearing all of that in mind, have a go at our question 4 today. Okay, so the work function is the minimum energy required for an electron to escape from the metal. And then the formula for maximum kinetic energy is that for the first mark. But we've got maximum kinetic energy on the y-axis here. So if we rearrange and then compare to the equation of a straight line, this is what I've got on the y-axis, and F is what I've got on the x-axis. And so that's going to mean that the gradient has to be h, Planck's constant, and the y-intercept is going to be minus the work function. And we get 1 mark for writing the comparison there, and then a 2nd mark for saying what the gradient and the y-intercept are equal to. Then for the next part, we use that. So there's our gradient calculation. You can read off to the nearest half square, but actually here, as long as you had a sensible triangle drawn, you would get the mark. And so my gradient comes out as this. Now it's joules divided by seconds to the minus 1. So that's joules seconds. And the gradient is h. So that's the next bit. And then the threshold frequency is the frequency that just allows the electron to be released. And that means it's released, but it doesn't have any energy left over. So that's going to be 0 kinetic energy. And so it's there. And they will let you have anything from 8.5 to 9.0, but they won't let you have 9. So you've got to meet the sig fig requirements there. And then lastly, the work function of the metal. Well, we just have to put numbers in the formula here. So I'm going to take that point there, which is 0 kinetic energy. And here I'm using my value of h from the gradient and my value of the threshold frequency. And you will get carry through marks. And so that gives you a value for the work function of this many joules. They do ask for it in joules, but notice it would be 3.5 electron volts.